In this fourth higher maths straight line video, we're going to have a look at three special lines: perpendicular bisectors, medians, and altitudes. Okay, looking at the perpendicular bisector first of all. A perpendicular bisector of a line is a line that crosses the midpoint of a line at 90 degrees. For example, find the equation of the perpendicular bisector of the line joining P, 0, 4, and Q, -2, -6. Firstly, we need to find a point on this perpendicular bisector. The only point we can find will be the midpoint of PQ. So we need to find the midpoint of PQ. So if I look at it, the midpoint. Remember, we add the coordinates, so 0 plus -2 over 2, and 4 plus -6 over 2. Okay, so that gives me -2 over 2 is -1. -2 over 2, again -1. So we've got the point -1, -1. We now have a point on the line. The next thing we're going to have to do is work out the gradient of this perpendicular bisector. But before we can do that, we have to work out the gradient of PQ. So if we look at it, the gradient of PQ, remember, that's going to be y2. So -6 -4 over -2, take away 0. If you work that out, that's -10 over -2. Minus divided by a minus is plus. 10 divided by 2 is 5. Okay, so we've got 5 for the gradient there. But we don't want the gradient of the line, we want the gradient of the perpendicular. So remember this, m2 equals -1 divided by m1. So what we've got here is for our perpendicular line, m2, we've got -1 divided by 5. Which is just -1/5. Okay, so now we've got the gradient of the line we want and a point on it. So at this stage, we're going to use y minus b equals mx minus a. So y, now -1 is +1, equals the gradient, which is -1/5. Remember, it's the perpendicular gradient we wanted. X plus 1, because it's -1. Okay, because remember, that was A, that's B, and this is the gradient we are using here. Okay, I would suggest with this one, why not just multiply by 5? So we've got 5y plus 5 equals -1 through this thing, give me -x minus 1. Okay? Take everything to one side, you'd have x plus 5y plus 5 plus 1 is 6 equals 0. And that would be the equation of the line. You could write it as y equals, the other way you could have written this is rearrange this thing and have y equals -1/5 x. Now that's -1/5, take away 1, it would be -6 over 5. You could write it like that if you wanted. However, I think that's probably a neater way of writing it, but you can't just leave it like that, remember. I'd suggest writing it like that, unless they specifically ask you for that, I'd write it like that, it's easier. Okay, if you want practice at these, remember it's Hodder Gibson and it's exercise 1.6. Okay, Hodder-Gibson exercise 1.6. Okay, those are perpendicular bisectors. Okay, the next line we're going to have a look at is the median of a triangle. The median is a line that goes from a vertex, a corner, like there, through the midpoint of the opposite side, like the midpoint of the opposite side. For example, a triangle ABC has points -4, 7, 1, -7, and -2, 3. Find the equation of the median through B. So it goes through that point, so we want the midpoint of AC. Okay, I've called the midpoint of AC M. So M will be equal to, now remember we add and divide by 2 with these, don't we? We add and divide by 2. So, -4 -2, so -4 plus -2, and the other one's going to be 7 plus 3. 7 plus 3. -4 plus -2 will give you -6. Okay, -6 over 2 is -3, isn't it? Yes? The other point, 7 plus 3 is 10, divided by 2 gives you 5. So you've got -3, 5. Remember, that's a -4 there. Okay, we've now got the other point on our line. So we've now got B and M. So we need to work out the gradient next. So the gradient of BM, yeah, remember, so we're going to have y2, which is 5, take away B, remember B was -7, so it's -7, over -3, take away 1. Now that gives me 12 over -4, which is -3. If we look at the diagram, that looks about right because it's negative and it's steep, the line joining M to B, isn't it? Now we've got the gradient of the line, and we've got, well, we can use either of the 2 points we like. We can either use this one we worked out, or B, this one here. I'm going to use B with this. So remember, we're going to use y minus b equals m x minus a. We've got our gradient, it's -3. I'm going to use that as A, that as B. Remember, it's either that one or the midpoint I could have used. I could have used this one and called that A and that B. Give me the same answer in the end. So we've got y minus -7 equals -3 x minus 1. Okay, must tidy it up. So we have y plus 7 equals -3x plus 3. I think we can do it either way. We can write either y equals -3x minus 4 if we take 7 off each side, or if we take everything to the other side, I could have written 3x plus y plus 4 equals 0. Either of those two will be fine. Now, if you're working from the Hodder-Gibson book, you get more practice at these sorts of ones with exercise 1.7. That's the second of our 3 lines, the median. Okay, the last line we're going to have a look at is the altitude of a triangle. The altitude of a triangle is a line from a vertex, a corner, perpendicular to the opposite side. So it goes through a corner and it is perpendicular through the opposite side. Okay, now an example. In triangle ABC, there's a little sketch of it down there, A is 2 minus 4, B is 3, 1, and C is -5, 0. Find the equation of the altitude through A. So it's going through A, perpendicular to BC. So the first thing we have to do is we have to work out the gradient of BC. We can do that. Remember y2 minus y1? So y2 is, we're talking about BC, 0. y1 is 1. x2 is minus 5. x1 is 3. So what we've got there is we've got minus 1 over minus 8, which is 1 over 8. Okay, because a minus divided by a minus, positive. Now, the perpendicular, remember, we do minus 1 divided by the gradient of the line we want it perpendicular to. So let's have a look at this. What we've got is, we'll call it M2 for the perpendicular, minus 1 divided by 1/8. Remember, if you divide by a fraction, turn it upside down and multiply, and the only thing multiplying by minus 1 does is change the sign. So that'll become minus 8. Minus 8 over 1, but we'd write that just as minus 8. Okay, we've got everything we need now. We've got the gradient here of the perpendicular, and we know the point because look, that's A, that's B. Yes, because we're told it goes through A. That's the only point we know on the line. So we're using 2 minus 4, as I said, that's A, that's B. We've got our gradient of the perpendicular is minus 8, and we're using this equation, which you should really be remembering by now. Y minus B equals mx minus A. Okay, let's work that out. So, y, now minus 4 is plus 4, equals the gradient's minus 8, x minus A, which is minus 2. Can't leave it like this, we've got to tidy it up. So, y plus 4 equals minus 8x plus 16. Now, we can either use y equals mx plus c form or take everything onto one side. If you do the y equals mx plus c form, that's going to be taking 4 off each side, so it's minus 8x plus 12. If you chose the other way, taking this to the other side, you've got 8x plus y. 4 take away 16 is minus 12 equals 0. Either of those two is fine. That's, now if you want some more practice at these altitudes, you want to be looking at Hodder-Gibson exercise 1.8. Okay, that'll give you plenty of practice on altitudes. Now you need to know the definition of these 3 lines. You need to know the perpendicular bisector, the median, and the altitude, because they don't always give you a nice little diagram to go with it. So you need to be aware of the definitions of these lines and what to do in each case. That concludes this video.